This is January 2018 paper. You can also use a chat for any question. If you think you know the answer, you can just simply use a chat and state the answer. So the first question, the half-life is basically half-life is a time taken by half of the reactant to react and form a product. So time taken by any concentration. So time taken by any concentration to be half of the original value, this we called a half-life. Like example, if I have 100 gram per centimeter cube, how much time out of 150 grams will take to form a product? We call that as half-life. Same thing, out of 50, 25 grams, how much time it will take to form a product? We call that as half-life. So time taken by half of the sample or half of the amount to react and form a product is refers to half-life. Not half time to complete, not half the time. It is basically time taken by half of any concentration or any concentration to become half of its original value. We call that as a half-life. When dilute aqueous solution of a potassium manganate 7 and ethane dioic acid are mixed, the following reaction occur. The rate of a reaction is slow at the first. So in the beginning, the reaction is slow, but the reaction increases. This is called self-catalyzed reaction, because what happened in the beginning, we don't have Mn+2 is actually acting like a catalyst. So in the beginning, we don't have Mn2, that's why the reaction is slower. But with the passage of the time, the reaction is catalyzed by manganese 2 ions as they form. That's why the reaction speed up. So in the beginning, it is slower, but with the passage of a time, it increases. In each of the graph, quantity Y is plotted against X. In which graph is the concentration of a product? Y is the concentration of a product and time. So if concentration and time, remember, like if we have a concentration time graph, the slope represents the rate. And because first order reaction, and they're asking about concentration of a product. If it was a concentration of a reactant, then it should be like this. It should be a straight line, because zero order reaction, the rate is constant. Rate does not change. So rate constant means it should be a straight line. So if they say concentration of a reactant, then it should decrease. But in the question, they're mentioning concentration of a product, so it should increase, but with a constant rate, so it should be a straight line. So which graph is a straight line from origin? So graph Q is a straight line from origin. That's why B is the right answer. In which graph Y is the rate and X is a concentration for first order? So again, for first order reaction, rate and concentration are directly proportional. So when two quantities are directly proportional, there should be a straight line which is passing through origin. So rate and concentration graph, it should be a straight line which is starting from origin. So again, Q will be the graph Q will be the right answer. If it was this is for first order. If it was a second order, then how it will be? Like this. If it was a zero order, like zero order is not affected by change in concentration, so rate will remain constant. Potassium nitrate is very soluble in water. The solubility of potassium nitrate increases rapidly with the temperature. So what happens when the temperature increases? So if the temperature increases, the entropy of a surrounding because less negative, that is true, because entropy of the surrounding is minus delta H by T. So if the temperature increases, temperature rises, so this whole factor will decrease. So temperature of the surrounding and the total entropy is equals to system plus surrounding. So system is constant. So surrounding will change and it becomes so less negative as the temperature increases. So more likely the final result will be positive. So that's why A is the right answer. In question 5, consider the following reaction in a gas phase. What is the order of increasing entropy? Entropy increases if the number of the particle or the moles of a gas increases, so entropy also increase. So when you check here, there are 4, 2, this is 3, 3, and this is 4.5 and 5. So here the moles increases, so entropy increases, entropy remain constant, and here entropy decreases. So starting with the most negative, the negative one means in which the entropy decreases. So that is F followed by G and H. So F, G, H, A will be the right answer. So entropy depends on number of the particles as well as the state of a substance. The standard molar entropy of a substance is 0 for all. So in the element, whenever particle, like at 0 Kelvin, the particles are not moving. That's why they don't have any energy to move. That's why it is 0. Then important reaction for extraction of iron, equilibria Kc. So Kc is product divided by reactant, but state symbols are always important. Solid, 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 and gas. So this is a heterogeneous equilibria. In heterogeneous equilibria, we only include gas. So that is a product divided by reactant. So carbon monoxide will only be included. Reactant, in the reactant, we don't have any gaseous state. That's why we don't include. The graph shows the variation of a temperature on the yield. So as we decrease the pressure, yield increases. And as we increase the temperature, yield also increases. So it means the forward reaction is endothermic. Endothermic reaction, entropy change should be positive. And when we are increasing a pressure, like 200 become 150, when we decrease the pressure, so remember, increase in pressure, shift the equilibrium towards the side where less moles are there. And decrease in pressure, shift the equilibrium towards side where more moles are there. So when we decrease the pressure, we are getting more product. It means the product side is having more moles. So number of the moles increases, and the enthalpy change of a reaction is positive because the reaction is endothermic. The relation between the hydrogen and iodine may be represented by two equations. Equation 1, equilibrium Kp, for equation 2, Kp2. So how they are related, what is the relation between, if I write Kp1, that is the product divided by reactant. So product is hydrogen iodide pressure. That is pressure. So pressure of hydrogen iodide square divided by pressure of hydrogen and pressure of iodine. And this is Kp1. Then Kp2, the second reaction, product divided by reactant. So pressure of hydrogen iodide divided by pressure of hydrogen under root and pressure of iodine also in a root, because power 1/2, this coefficient will become power. How we can relate? If I make a right hand side equal, the left hand side will also be equal. So this equation is, if I square both sides, this will become square. This square will cancel with a root. So now right hand side is equal. So left hand side will also be equal. So I can say KP1 is equals to KP2 square. So KP1 is equals to KP2 square. So for question 9, C is the right answer. In question 10, PCl3 plus Cl2 gives PCl5. Kp, how Kp is not affected, Kp is only Kc or Kp is only affected by changing the temperature, not amount of the reactant or pressure. So Kp will remain unchanged if we change the pressure. But mole fraction, because if we increase the pressure, equilibrium will shift towards side where number of moles of a gas are less. So here 2 moles and 1. So equilibrium shift towards right hand side. So the number of the mole, it will shift towards right hand side. So mole fraction or amount of PCl5 or yield will increase. So for question 10, C is the right answer. In question 11, when concentrated sulfuric acid is added to ethanoic acid, the following reaction occurs. So when we mix two acids together, the one which loses proton, like H2SO4, is acting like an acid. So forward reaction, this is acid, this is acting like a base. So acid 1, and this is base 2. And when we take the reverse reaction, when we check the reverse reaction, so in a reverse reaction, it is HSO4 become H2SO4, so it is accepting. So this one is base 1. And here this is acid 2. So when we check, acid 1 is H2SO4. All the options, H2SO4 is an acid. HSO4 is a base 1, that is true. And CH3COOH2 is an acid 2. So D is the right answer, because acids are proton donors, bases are proton acceptor. So when you see the forward reaction, H2SO4 become HSO4. So this is, for a forward reaction, it is acting like an acid. But a reverse reaction, this is acting like a base. So if we say this is acid 1, we call this as a base 1. Then 0.1 mole per dm cube sodium hydroxide is titrated with 25 cm cube of ethanoic acid. What is the best indicator? So an alkali, strong alkali is used with a weak acid, so phenolphthalein as an indicator. You have to learn the vertical part and the type of the indicators which we can use for strong acid, strong base, weak acid, strong base, weak acid, strong base, weak base, strong acid. Then for ethanoic acid, pK is 4.76. The pH of a solution of ethanoic acid of concentration 1 into 10 power -4. So basically, we have the concentration, we have the pKa. So using this, we will work out. So this question I will solve a minute left. I'm sharing another, I will share another link and I will solve this question 30.